And so here is that second problem, which I said I'd look at more extensively. This one deals with the idea of supply and demand. Here is a picture from our textbook. Keep in mind that this is a foundation of economic theory, and we have one page of it in our textbook. There's really not enough there to even begin to wrap your head around these ideas, and I thought I'd just explain it to myself so I could explain it to you and encourage you to go on for more on these ideas. Now, essentially, we have a supply curve and a demand curve, and in this problem, these are given as lines. And the idea here is that notice the x-axis is, in this case, it's money. And the y-axis here is quantity of a particular good. We're looking at just one good here. Now, supply is from the manufacturer's perspective or the store's perspective. And the idea there is that as an item increases in value, the amount of money you'd make from selling it is an incentive for you to sell more. And so supply has a positive slope that manufacturers will rush to fill orders as the costs increase because they can make more money. On the other side of that, when something drops in value, they won't be compelled to make as many of them. Now the demand curve is from the consumer standpoint, and that says that as the price goes up, there's less consumer demand for it because less people can afford it. At $12, there's only a demand for 5 of these widgets. Conversely, though, as the price goes down, the demand for that object will go up because more people can afford it. There'll be a demand for 25 of these things at $8. And so the demand curve is D for down, and the supply curve is a positive slope, and this is a negative slope, and because their slopes are different, they're going to intersect at a point, and this turns out to be the equilibrium point where when you walk into a store, supposedly the goods you see priced are going to be near that equilibrium point. It's where the demand and the supply come together at this unique price. So, that's the essentials of what's going on here. Mathematically, we're talking about a system of equations, and we're talking about a intersection point. And so what I've done here is I've rewritten those two equations upstairs there, showing that their left-hand side is in fact the same variable. Now, P is for price or money, and that's what we input, and the output is the demand or the supply quantity. But it's quantity nevertheless. It's the same variable. And so we have a system of equations, and we want to solve it for the intersection point. I only use the same technique I used in the preceding problem, substitution. Quantity is equal to this, so I'm going to take this and plug it in, and we now have an equation in one unknown, and so we can solve that for P. Add 60p to both sides, subtract 400 from both sides, and I get this, and it's very easy to do. We discover that P is equal to 50. Of course, we're talking about an intersection point. Sub that 50 into either one of those equations up there, and I chose the second one, which generated this situation. And when you do the math on that, you get Q is equal to 2400, giving us the ordered pair 50, 2400. That's the ideal price at $50. Suppliers will be willing to create 2400 of these widgets, and the consumers will be willing to buy 2400. That's what's going on here. But like I said, these are really deep ideas. These are the foundations of our economic system, and it's well worth trying to wrap your head around as opposed to the really crummy job that our textbook did. So that's what I want to input into our MathXL, 50, 2400. Let's ask it to evaluate our two problems. And as you can see, we got them correct. Well, I hope that helps. Sorry to take up so much of your time, but I like to explain these things to myself, and that means I need to go deep, and or else, we're really not understanding anything. We're just going through the motions. So I'll be talking to you again.